Welcome back to Wonder Channel. In this second part of the Monomials video sequence, I will talk about the canonical form and the degree of monomials, and equal and similar monomials. Has been said in the first part of this video sequence, and by the definition of monomials, in a monomial we may distinguish a numerical part that can be called coefficient, that comprises the constants or the products between them, and a literal part that encompasses the variables or also the products between them. In this case, for a is a numerical part, or the monomial coefficient, and x to the power of 5 multiplied by y to the power of 2 is the literal part. As previously seen, we may have monomials that only have the numerical part. For instance, the number 4 called a constant monomial, or even 0, the zero monomial. A convenient way to represent a monomial is by its canonical form. For example, computing the area of this rectangle with this length and width, and applying the formula of the rectangle area multiplying the length and the width, or the width and the length, is the same thing because the commutative law is applied in the multiplication of two numbers or variables. This will result in this expression. Now, to represent in the canonical form, we reorganize the parts, giving us this result. So, this representation consists in writing the numerical part first, and then the variables in alphabetical order. The degree of a monomial can be seen as the sum of the exponents of the literal part, when this one exists, of course. For example, this is a monomial of the 7th degree. Adding the values of the exponents x and y, respectively 5 and 2, will give us its degree, 7. It can be seen that the constant monomial, a monomial with a numerical part only, for example 5, will have 0 degree, since the degree is given by the literal part that doesn't exist in this case. Our little friend x to the power of 0 indicates our 0 degree by its exponent. Now let's talk about equal monomials and similar monomials. Equal monomials are monomials that have the same canonical form. For example, these two monomials have the same canonical form. Thus, they are equal monomials. The similar monomials are those that possess the same literal part. As an example, these two monomials are similar. This is their canonical form, verifying by this way that they have the same literal part, and by this they are similar monomials. If you have any questions, comment below. Thank you for watching, and if you liked the video, don't forget to subscribe. See you in the next video.